Alright, production of materials, part 3, ethanol as a fuel. Going to be talking all about ethanol today. It's all ethanol. So let's get into it. Ethanol's chemical formula is C2H5OH. And let's have a look at the structural formula. It's just 2 carbons. It's got hydrogens all around. I'm not going to bother drawing the hydrogens because it's a waste of time, but do so in your own diagrams. So it's carbon with hydrogens all around, like a hydrocarbon, but on one end it's got this all-important hydroxyl group. It's an OH instead of just an H, and this gives it all kinds of special chemical properties, which we'll get into a bit later. And yes, so that is ethanol. Very important. Known in the community simply as alcohol. It's in alcoholic beverages, but we're not going to be talking about its use there. We're going to be talking about its use as a fuel. So there's 2 ways that ethanol can be used as a fuel. One way is simply to burn it, just combust it, mix it in with other fuels and burn it pure. That's one way. We'll get into that in a bit. The other way that we could end up using it as a fuel is if we didn't have any petroleum, didn't have any hydrocarbons, we might want to use ethanol as a hydrocarbon source. So let's do that reaction now. The reaction is a dehydration. Wow, good handwriting here. Dehydration reaction. So that is the class of reaction. If you want to know if you're converting ethanol into ethene, which is going to be our eventual product, what kind of reaction would you use? Or if you wanted to convert ethanol for its use as a substitute for hydrocarbons, it's a dehydration reaction. Alright, so let's have a look at what the reaction is, because we need to know the details of it. C2H5OH, so that's our ethanol. Now, with concentrated acid, it's H2SO4, sulfuric acid, or phosphoric acid, will create, now, one of the products is going to be H2O, that's the dehydration aspect of it. And what's going to happen chemically, just in case you're interested, is this H over here, this OH, might as well draw that one in. H. Basically, they come over here, form H2O. They come out, and what is left over is C2H4. Should be looking pretty familiar. In case it isn't, this is its structural formula. So that's ethene, ethylene. We've dealt with that one before, and as you'll know, we can use that as a source for lots of different hydrocarbons. Can combine it into combine it with hydrogen and create ethane, and then basically we can use it as a source for a lot of the things that we use hydrocarbons for. So that's what we would do if we suddenly ran out of oil, ran out of petroleum, ran out of fossil fuels, and we needed to use a natural source, and we can derive ethanol from natural sources to create the hydrocarbons that we're currently getting out of the ground. The situation at the moment, though, is actually the complete reverse, and we're going to have to look at the reverse reaction as well, because that's what's going on at the moment. So at the moment, we actually need so much ethanol that the cheapest way to produce it industrially is to reverse this reaction and actually get it from ethene. So we're not producing ethene from ethanol at the moment. We're actually doing the opposite. So this is one of the major ways that we produce ethanol. Just come over here. So we start with C2H4, and then we use that to produce ethanol. How do we do it? Well, we actually use a dilute acid this time, so an acid and water. And the reaction basically just is the reverse of it. It goes to C2H5OH. So it's essentially, because of this, it's a dilute acid, it's got water in it, it's essentially plus H2O up here. And yeah, that's pretty much it. There is a two-step process that they have asked about in the HSC before. Now, the way to represent the two-step process, so this is the two-step process for the conversion of ethene or ethylene into ethanol. So this is the opposite of a dehydration reaction, by the way. You're adding in water, so it's a hydration reaction. Quite simple. So it's a two-step process. So we'll represent the C2H4 as two CH2 groups in one molecule, plus our H2SO4. So the first step in this is that the acid adds on to the ethene. I'm going to run out of space on my screen here, so just draw this down here. So that goes to CH3, CH2, and then HSO4. So basically the acid combines in, and then this is then the chemical that reacts with the water. And one of the products is the acid, so it's just a catalyst, it's not consumed in the reaction, and our final product is C2H5OH. So yeah, you will need to know this, that there's this intermediate product which is called something like ethyl hydrogen sulfate is the intermediate product, and then yeah, so the acid combines to create this, and then that reacts with the water, but in the end the acid comes out anyway, and yeah, we've just reversed the reaction that we saw when we dehydrated it. We've now hydrated it and created our ethanol back from ethene. So this is actually what goes on at the moment. Alright, so what else can we do to produce ethanol? Yeah, alright. So yeah, that's the industrial source of ethanol, but we also have a biological source of ethanol. Now, the thing about an industrial source of ethanol is that because originally it's just a fossil fuel, and then we've converted that to ethanol, when we burn that ethanol, it's like burning a fossil fuel. So it's no more carbon neutral than burning fossil fuels, which isn't carbon neutral at all. So there's no point to converting ethene to ethanol and then using it as a fuel. You might as well just use the hydrocarbons you've got as a fuel in the first place. But if we get our ethanol from a biological source, then when we eventually burn it, it is a carbon neutral, or well, it's not quite carbon neutral, but it's a more carbon neutral process. So there's a lot of interest in creating ethanol out of biological sources. That's something that's been going on for a long time. It's how we've always gotten it's how we've traditionally gotten our ethanol.